Hey there, pre-cal students. We're doing lesson 3 today. It's all about verifying inverses. A couple of the examples have rational functions, so the process is the same every time, but please pay attention to the process because it's important that you are able to simplify those. Okay, so without any further mention, here we go. Okay, we're looking at lesson 2.3, verifying inverses. So this is all about how we algebraically verify whether two functions are inverses of each other. We had said in the very first lesson of this unit, this statement right here, okay, that f of g of x is going to be equal to x as well as g of f of x. Well, I think we were writing it as inverses though. That we had said that, let me just write it out here to the side, f of f inverse of x equals x, and we had said f inverse of f of x equals x. Okay? So, if we just kind of replace f inverse here with g, what we get is this right here. So this is how we're going to verify it. To verify algebraically that two functions f of x and g of x are inverses of each other, we show that f of g of x equals x and g of f of x equals x. And we do have to do both parts, okay, to verify it completely. All right, so the rest of this is just we're going to go through 3 examples of verifying whether the two functions are inverses of each other. So here we go. Determine algebraically whether the two functions given are inverses. Our first, number 1 says f of x equals root x plus 2 and g of x equals x squared minus 2. And we have a restricted domain there where x greater than or equal to 0. Okay, that goes along with kind of what we were talking about in lesson 2, that we restrict the domain of that so that it does have an inverse. So let's start with f of g of x. So we're going to take g of x, we're going to plug it into f. We're going to say f of x squared minus 2. So we're going to take x squared minus 2, we're going to plug it in where the square root, into the square root, where the x is. So we'll say x squared minus 2, and we have a plus 2 here. Well, minus 2 and plus 2, the parentheses really don't make any difference inside here, and the minus 2 and plus 2 are simply going to cancel, and I end up with the square root of x squared, which equals x. So that works. Now let's do it the other way, g of f of x. Alright, so this is g of the square root of x plus 2. So I'm going to take square root of x plus 2 and plug it in for the x here. So square root of x plus 2, we're going to square that. X squared minus 2, so this is my x squared minus 2. When I square the square root, it cancels and gives me x plus 2. And then I still have this minus 2. The plus 2 minus 2 cancel, equals x. So yes, they are inverses of each other. Okay, so that is how we algebraically show that two functions are inverses. Alright, these last two both have rationals. I've got x plus 1 over x for f. I've got 1 over x plus 1 for g. Okay? So here we go with this one. I'm going to start with f of g of x, which will be f of, my g of x is 1 over x plus 1. I'm going to take this, I'm going to plug it in for both x's here. So 1 over x plus 1 divided by 1 over x plus 1. So when I get fractions inside of fractions, we call this a complex fraction. And when I get fractions inside of fractions, the way to get rid of that is to multiply top and bottom of my big fraction by the common denominator of my fraction within. In other words, I can see, you know, I've got a denominator of x plus 1 in this little fraction. I've got the same denominator here, x plus 1. So I'm going to multiply x plus 1 on the top and on the bottom. Alright? On the bottom, it works out nicely because it just is going to cancel out. X plus 1, you can think of this as over 1 if you want, but it's just going to cancel out. Okay, so it leaves me 1 on the bottom of this fraction. On the top, I've got to distribute it. I'm going to have x plus 1 times the fraction, and then I'm going to have x plus 1 times the 1. When I multiply it by the fraction, the x plus 1's are going to cancel, and it leaves me 1. Plus 1 times x plus 1 is x plus 1. Alright, so now I don't really need to divide it by 1. I don't really need to worry about that so much. On top I've got 1 plus x plus 1, and that is x plus 2. So this does not equal x, and at this point I can just stop. Sorry, it went off the screen there. Alright, at this point I can just stop and say, alright, it's not equal to x, therefore, no, they are not inverses. I do not have to go any further. Okay? One more example on the back. And again, we have rationals here. Rationals are a little tougher, but we can do it. Okay. So we'll start with f of g of x, and that is f of 3x plus 5 over 1 minus 2x. So I'm going to plug into this x, I'm going to plug into that x. 3x plus 5 over 1 minus 2x minus 5, that's my x minus 5, over 2 times 3x plus 5 over 1 minus 2x. There's my x, 2x plus 3. Once again, I'm going to use the same process that I used on the last problem, and that is my common denominator between these two smaller fractions is 1 minus 2x. So I'm going to multiply times 1 minus 2x on top and on bottom. And again, if you want to think of this as 1 minus 2x over 1, if that's helpful to you, then do that. Okay? Now on both of these, I'm going to have to distribute. I'll have to do 1 minus 2x times this, times the fraction, and then 1 minus 2x times the 5. On the bottom, same thing, 1 minus 2x times the fraction, 1 minus 2x times the 3. The 2 is part of this first term, so I don't need to multiply it times the 2 and also the fraction, because all of that is just one term. Alright, so let's see what happens here. On the top, when I do 1 minus 2x times the fraction, the 1 minus 2x is going to cancel, and I'm left with 3x plus 5 over 1, which is 3x plus 5. Minus, I'm going to have 5 times 1 minus 2x, because I've got to do that 1 minus 2x times the 5 as well. Okay? On the bottom, 1 minus 2x times this, 2 times the fraction. Again, the 1 minus 2x's are going to cancel, and I've got 2 times 3x plus 5 plus 3 times that 1 minus 2x. Alright, so I've got a lot of stuff here. I'm going to distribute everywhere I can first, then we'll gather like terms, and then we'll simplify whatever we can. Okay? So let's start by distributing. 3x plus 5 minus 5 times 1 minus 5. Minus 5 times a minus 2x will be plus 10x. On the bottom, 2 times 3x is 6x. Plus 10, 2 times 5. Plus 3, 3 times 1. Minus 6x. 3 times negative minus 2x, it's going to be minus 6x. Alright, let's gather like terms. On top, I've got 3x plus 10x, that's 13x. And then the plus 5 minus 5 are just going to cancel out. On the bottom, my x's cancel. 6x minus 6x cancels. I've got 10 plus 3 is 13. 13x divided by 13 is x. So that does work. Alright, that does work. So let's work it the other way. G of f of x. G of f of x. G of x minus 5 over 2x plus 3. So I'm going to take that and plug it in for the x here and for the x here. So 3 times x minus 5 over 2x plus 3 plus 5 divided by 1 minus 2 times x minus 5 over 2x plus 3. Once again, I'm going to multiply by that common denominator on top and bottom, 2x plus 3 over 2x plus 3. We're going to distribute that, 2x plus 3 times each of these terms, 2x plus 3 times the 1 here, 2x plus 3 times the fraction. So on top, it's going to cancel out, the 2x plus 3's will cancel with the fraction here, and I'm left with 3 times x minus 5 plus 5 times the 2x plus 3. On the bottom, 2x plus 3 times 1 is 2x plus 3, minus, on the fraction it's going to cancel, I'm left with 2 times x minus 5. Alright, back to the top, let's distribute. 3x minus 15 plus 10x plus 15. On the bottom, 2x plus 3 minus 2x plus 10. Back to the top. My 15's cancel. I'm left with 3x plus 10x is 13x. My 2x's cancel on the bottom, and I'm left with 3 plus 10 is 13 equals x. So, yes, inverses. So there we go. That is how we verify whether two functions are inverses algebraically. Okay?